Okay, good everyone. On this episode, we'll be looking at uh, naming of organic compounds. The IUPAC naming of organic compounds. Now, to the IUPAC naming of organic compounds, what we need to understand is that the names can either be in trivial form, can be a trivial name, common name, and as well could be a systemic name. Now, what do we mean by IUPAC naming? IUPAC, the full meaning of IUPAC, the International Union of Pure and Applied Chemistry. So you need to know that. So this International Union of Pure and Applied Chemistry came with a set of rules, and then they decided to begin to use that rule in naming organic compounds. That was in the year 1892. So we call this to be 19th century. So we call this to be the 19th century, 1892. So once it's 18, 17 something, so it has gotten to 18th century. I hope you understand what I mean now. So this is 19th century. So they decided to gather those rules and began to give up a systemic naming of organic compounds. Now they decided now to bring up four parts to this systemic naming. The four parts to the systemic naming was in a form called LPPS. This LPPS is what we abbreviated to be L as the location, P as the prefix, the other P as the parent, and the S as the suffix. So meaning that whenever you're naming organic compounds, these four parts are very, very important and they need to be present. Now, organic compounds can be named or can be classified based on in naming them. You also need to know their classes so that it will be a better avenue to your naming, to help in your parent naming your suffix. So you need to understand that to help in the parent naming and the suffix. So the classes now depend on the parent name and suffix. The classes of organic compounds are four. They are four. They could be they are aliphatic. We have alicyclic compounds, aromatic compounds, and the heterocyclic compounds. Now all these are actually based on the shapes. So we need to understand that. So the classes of organic compounds could be based on the shape or let's say the carbon skeleton. This carbon skeleton. What do I mean by carbon skeleton? Carbon skeleton can also be called bond line formula. Now, bond line formula or carbon skeleton means the same. Maybe for example, you have a structure like this. This is an example of bond line formula. Now, meaning that your carbon structures or bonding has now been represented in form of a lines, carbon skeleton. Now, we are still going to talk about bond line formula, but the first one is of classifying organic compounds first based on the carbon skeleton. Another is also based on functional groups. Now, this classes is just 4, but based on the functional group they are much. Now functional groups actually gives physical properties and chemical properties of hydrocarbons. So it's which actually determine the chemical and physical property of some compounds. So the physical property of some compounds are, let's say, in their derived or determined by their functional group. So this functional group, for example, now we have OH, which is alcohol. Yes, we also have other functional groups like uh, carboxylic for, let's say, like uh, ethanoic acid, CH3COH. So this becomes the functional group. So this will actually determine the chemical properties and physical properties of the compound. We also have amide, we have thiol, that's presence of sulfur. Well, a lot. So now what we need to understand is just this. I'm just trying to bring an introduction to what we need to do or to know. Now homologous series is also a criteria as well. Homologous series from our background knowledge in senior secondary schools, we should understand that homologous series is a series in which the member of that family differ by a bond CH2 group. What I mean by bond CH2 is that CH2 group. So this is a criteria to defining homologous series. That's what I need you to understand. Now, you don't just say CH2. The bond line formula must be there and CH2. So in every successive member, for example, we have alkane, and for alkane family, a carbon 1 atom. So the difference between one carbon atom and 2 carbon atom, which is ethane in ethane family, is the difference of CH2 group. Just trying to establish a background knowledge about that. So that's just some things we need to remember or recall. Now aliphatic could be either branched and unbranched. It could be either branched or unbranched. Now this unbranched can exist in 3 forms. We have 3 families in this unbranched. This unbranched could be single bond, double, or triple. Now this is what I mean. The single bond is otherwise known as the alkane family. The double bond, this like this, then the double bond 1, 2 could also be known or is known to be the alkane, and the triple bond is known to be the alkyne. So now that's what we just need to. Then the alicyclic, though we'll be picking all these one after the other, can exist in 2 forms. They can be simple and as well multiple. Now they can be simple or as well multiple. Aromatic, these are just derivatives of benzene family. Then heterocyclic, this part is what we will actually dwell much on, though well after creating the background knowledge on all this, we'll dwell much on heterocyclic. Now heterocyclic could also be simple and as well multiple. Now what is the main difference is that heterocyclic consists of lots of hetero, many many other elements. So lots of elements. Now, what we understand by heterocyclic, hetero, lots of other elements. Then cyclic, meaning that it is in a circular form, and this denotes closed. So meaning that the compound here, or the bond that exists, is a closed ring, just like aromatic compounds. Aromatic compounds has benzene ring. Then alicyclic as well is also a closed as well. Closed ali for aliphatic, cyclic, closed. And aliphatic is characterized to be alicyclic is also characterized to be an open chain. Open chain, that's aliphatic, can be branched or unbranched. Then alicyclic they are closed ring, which can be single or multiple. Which other aromatic, they consist of a benzene ring, like I said. Heterocyclic, they consist of a closed ring of carbons, which can consist of different elements like nitrogen, oxygen, and the likes. So they are also their bonds can also be in simple, or multiple. So those are just what we just need to know in establishing the introduction of organic compounds. So now another thing you need to also note is that from here we'll be moving to unbranched aliphatic. So for the unbranched aliphatics, we'll be looking at the first one, which is the alkane. Now the alkane is in has a molecular formula of CnH2n plus 2. So that's molecular formula or general formula of CnH2n plus 2. Now their names, or the simplest of this family, is the methane, ethane. Now in naming this family, members of this family, we need to understand this. We have methane, ethane, propane, which is 3. I think we should have known this. Propane, which is 3 carbon atom. Propane. The suffix in this family is ane. So all you just need to understand is the first name. Do you understand the prefix? 4 carbon is what? 4 carbon is butane. 5 pentane. 6 hexane. 7 heptane. 8 the octane. Then 9 carbon atom, nonane. 8 octane 9. Then 10, that's where we need to be careful in our naming of alkane family. So here we have decane. So when we get to 11, it becomes undecane. 12 dodecane. Be careful when it gets to 20. 13 becomes tri. 14 becomes tetra. 15 becomes penta, and 16 becomes hexa. 17 hepta. 18 octa. 19 nona. Then 20, now when it gets to 20, becomes ecozane. 21 now becomes n. Take note, 21 becomes n, not on again. N-ecozane, meaning that there is 21 carbon atom, which is ecozane. So when it gets to 22, it becomes do 22 becomes do eicosane, 23 becomes trieicosane, 24 becomes tetraeicosane, 25 becomes pentaeicosane, 26 becomes hexa, then just pick the eicosane as the suffix. So you understand now. So when it gets to 30 becomes tricontain. 31 here now becomes n for the 1. Then the 30 becomes tri, that's n tricontain. Then 32 becomes do tricontain. Do you get it now? So then it gets to 40 becomes tetracontain. Then 41 here becomes n tetracontain. So this just keeps going till it gets to 45 penta tetracontain. So all this is only the suffix prefix that keeps changing. This keeps remaining the same as it's going. Then when it gets to 50 it becomes pentacontain. Then just keep changing they keep adding to it. 51 becomes n pentacontain. Then it keeps going like that till it gets to 100. 100 is called, so 100 is hectane. So just like that. So if for example you ask what is 90, 90 should be nona a has to be there, nona contain. Then 91, or let's say 94, should be tetra nona contain. Do you get it now? So that's like if you ask for 75, 70 itself is 70, let's put it here, 70 is heptacontain. So 75 should now be pentaheptacontain. So do we get it now? So that's just what you need to know in the first introduction to organic chemistry and the alkane family first. Now we'll be treating the alkane family properly with the name. What do we have here? They said the name of the unbranched alkane CH3, CH2, CH3 is what? Now what you just need to count the number of carbon. You have 1, we have 2, we have 39. 39 is 40, 41. So this should be N41. This should be N40 tetracontain. So that's N tetracontain. So you get 41 N tetracontain. So you can also do well to check this very well. N tetracontain. That's for 41. All you just need to look at another question again. So we have what we call pentatricontain. Penta first should be 5. Then tricontain, that's 30. So this 35. Simple as that. So looking at the option, we have 35. So it's as simple as this when you are solving. I'll be dropping some other. It's just as simple as this. Penta 5, tricontain 35. So the first one we did was N tetracontain. Just count the number of carbon. This 39. This 39 plus 1, 40 plus 1, 41. So the 1, so the 1 there is N, then the 4 in the beginning is tetracontain, so that's 41. It's just as simple as this. So we'll be establishing more on this naming. Now in the next episode we'll be looking at the bond formula. And we'll be looking at the naming in general. So those are the two things we'll be looking in the next formula. So in the next episode. So do well to make sure that you subscribe to this channel, and as well click on the notification bell, so that as we'll be dropping the next episode of this organic chemistry, you would receive the alert of it, and you follow, so that in the next episode you'll be able to follow on with the bond line formula, which is also known as the carbon skeleton, and the naming. Under alkane, take note, under alkane we are looking at this first, aliphatic unbranched. So then we move to alicyclic, aromatic, and heterocyclic. All this will be in just 9 or 8 episodes. So do well to subscribe and click on the notification bell so that you follow. In this 9 episodes